Let's see here. Let me focus this a little better. There. Okay. Even if I zoom in on these two, so I try to solve by graphing, and I really try to get it right on the money there. 2.8, negative 2.09. I guarantee you that's still not the exact solution. It's close, but it's not. You're not going to find the exact solution by graphing, unless it's like 3, negative 2 or something like that. Okay? So we want to find the solutions not graphically, but algebraically. We want to do it and find an exact solution. That's actually better right there, isn't it? Okay. So today we're going to talk about how to solve a system of equations, not by graphing, but by something called substitution. Okay? So, just sit back, relax. You don't have to take notes. I want all your brain power focused up here. Okay? So here's how a problem like this would work. Let's say I give you one like, here's an equation. So here's a system of equations. This little brace around the outside, what it's telling us is x and y represent the same value in both equations. Okay? And we're going to find the place where they intersect. And we're not going to kind of find it. We're not going to get close. We're going to find the exact place. Okay? And we're going to use a system called substitution. So when we use this, what we hope is that one of the two equations, doesn't matter which one of them says x equals something or y equals something. One of the two equations is either solved for x or y. Okay? So see this top equation? See how it's solved for y? Yeah. So that's cool because I know what y is. What is y?
1. Wait.
It's negative x minus 7.
Yeah.
And then you guys are like, that's not helpful at all, Mr. Collard. You're like, how does that help us? Well, I'll show you how it helps us. Right here in this bottom equation, see right there where the y is? Instead of y, I can put negative x subtract 7. They're the same thing, right? They're the same thing, so I can substitute one for the other. Like in a recipe, if two things are basically the same, I can substitute one for the other. It's not going to make any difference, is it? Well, here, because y and negative x subtract 7 are the same thing, I can substitute one for the other. The question is, why the heck would I do that? What good does it do? What's the point? This is where I just sit here and wait for you guys to figure it out.
So you can find what x is?
But how can I find what x is? Why can I do that, Kylie?
Because
You can do that because there's no y. It's just x.
Yeah. See our new equation?
Yeah.
How many variables?
1.
1. Well, we can solve that. Okay, we can solve this. Now, here's some important stuff along the way. Notice, I replaced y with a set of parentheses and put what it was equal to inside the parentheses. That's a big deal. If you don't do that, it's not going to work. Okay? And then the next step is always going to be, okay, get rid of the parentheses. In this case, yeah, we didn't really need them. That was a bad example. But I get rid of the parentheses. I add like terms. I can move this, add 7 to both sides. Divide by negative 6. Now, I'm pretty sure at this point I'm on the right track, because look at my answer. See how it's an integer?
No, we should move.
In the book, the problems in the book, the answers are going to be integers. And that's just so that you know you're doing it right. Because if the answer came out to be, 2 3/4 or something, or some weird number, it would be hard to know that you were on the right track, you're doing it right. So this tells me, okay, I'm probably doing it right. I'm halfway done.
Yeah, you need to move it up. We can't see your answer.
Better?
Yeah.
It's always better when we can see it.
Yeah.
Okay, I'm halfway done. I found X. What do I still have to know?
Y.
What's Y? Well, guess what? I know what X is.
You just have to put it in the equation.
Yeah, so see that top equation right there?
I think I remember this.
Y equals the opposite. Now, I'm going to replace X with a parenthesis. And what goes inside that parenthesis?
Negative.
Negative.
Negative. Do you see why I replaced X with a parenthesis and put the -2 inside?
Yeah.
Everyone see that double negative, Jim? You seen that? So, Y equals +2, subtract 7, so Y equals -5. So if I were to graph these two equations, one would come along like this, and one would come along like this, and they'd intersect, right? And where would that point of intersection be?
-5. No, -2 is
-2.
We make it like that.
And that's actually how we give our answer. We give our answer like it's a point on the coordinate plane. Because that's what it is. It's a point of intersection. That's where it intersects. Now, how many of you have seen this before somewhere?
Oh, I think so.
I swear I have.
Okay? All right.
Wait,
How did that feel? Was that awful?
Can you do another one?
Oh, yeah. Oh, yeah. Definitely. Okay? So, let's go through the steps again. Let me find it. Let me find one that's...
Can you do it if one doesn't equal Y?
Okay, that's a good question. Let's just go there right now, okay? So, X subtract 6Y equals -11, and 3X plus 2Y equals 7, and we want to solve by substitution. So, neither of these equations is solved for X or Y, okay? And that's what we need. We need one of them to say X is this or Y is this, okay? But we can make that happen. So which of these two equations do you think you could like solve for X or Y, and would you solve for X or Y? Angel? Okay, the top. Everyone see the top equation?
Yeah.
Look at the coefficient of X. What is it?
1.
It's 1. We're close already, aren't we? We can solve that top equation for X really simply. Angel says just add 6Y to both sides. Okay? Now it's your choice. So whichever equation is the easiest for you to solve, that's what you do. So now I have this system, and now I'm gonna use substitution. So I'm gonna take what X is equal to, and I'm gonna put it right there where X is. And it's not always, we don't always know what X is. Sometimes we know what Y is. So whichever one it is. And then we have 3 plus 2Y equals 7. And then instead of X, in parentheses, we put -11 plus 6Y.
Wow.
Everyone see what I've done? There's a really simple test too. Am I on the right track? Am I doing this right? Well, look at our new equation. Do we still have X's and Y's?
Yeah.
No, we just
No.
have one variable.
Yeah, we just have one variable. So are we on the right track?
Yeah.
Yeah, we're on the right track. If you do the substitution and you still have X's and Y's, okay, you need to go back and look at this. What about the parentheses? What happens if I don't use the parentheses? Is that going to work?
You'll get
It'll get confusing.
It won't work, will it? You'll end up with 3 subtract 11 plus 6y. It's not gonna work out. So make sure that you replace whatever variable you're substituting for. Make sure you replace it with a parenthesis, and then put that inside the parenthesis. And then you can solve this. Should we do it? So -33 plus 18y plus 2y equals 7. Now, you guys are big boys and girls now, so I'm going to add my like terms. And I'm going to add 33 to both sides.
Yeah.
What do you think?
40.
Yeah, do y'all understand what I did solving the equation? I didn't show all the little tiny steps, but I did show my work, didn't I? Yeah, and I can divide both sides by 20. And y equals 2. And I'm probably on the right track because I got an integer, right? We're halfway done, Easton. Are you excited?
Oh, yeah.
Okay. Now, we know y. We still got to figure out what x is, don't we?
Yeah.
Okay. Well, remember, x equals negative 11 plus 6y. What's y? So x equals negative 11 plus 6 times 2. Negative 11 plus 12. Also an integer. That's good, right? That's good, right?
Yeah.
Okay. So, how do we give our answer? 1, 2, like an ordered pair. Make sure you put x first, then y.
Are you purposely making them even like that? Or
I am.
Oh.
No. You mean like 1, 2, or just integers?
No, just 1, 2. Like,
No, I'm not.
like both of them were
That was just the math god smiling on us. That does not always happen. You're going to get 8, negative 14, negative 7, 3. It's not.
No, I meant like point something.
Oh, yes. I am making them so that the answers are integers.
Oh, I thought
I keep using that integer word, but I don't think that's... Let's look at our poster over here. So I'm making the answers to come out to be integers, like 0, 1, 2, 3, or negative 1, negative 2, negative 3, and so on. Do you understand? If your answers are not integers, you didn't do it right. Now, on a real life problem, what's the chances the answer is going to be an integer?
no, right.
No, it's not going to happen, okay? In fact, if you get an integer answer, you're probably wrong, okay? But in math class, just to help us to kind of keep track of what's going on and make sure we're on the right track. Okay, so get out a blank sheet of paper. Okay, so here's our system. So first step is, you guys, you have to write down the original problem here. Okay? You're going to just have to do that. Just get used to it. So everybody write this down on your paper. And you hope that one of the two equations is either solved for x or y. Okay? In this case, is that, we got it? So everyone see this top equation? So, here's what I want you to do. I want you to put that 6y subtract 7 in parentheses. And then down in the bottom equation, where's it going to go? Where x is. Put the x in parentheses. So that's where it's got to go. It's equal to x, so that's what it has to be substituted for. So go ahead and do that substitution. I did mine in multicolor. Do you have the 6y subtract 7 in parentheses?
Yeah.
Okay? So everyone understands what we did. We took what x is equal to and we substituted it for x, and now look at our new equation. Do we still have two variables? No, we don't, do we? Okay. So Georgia's like, nope, Mr. Collard, you only have one variable. We're good to go now, right? Okay, so now what, Easton? Do it. Solve it. Gosh. Come on, man. Okay. I got one.
Yeah.
Yeah?
Thanks a lot. Me.
Questions?
No.
I didn't show all my work very well, but I did add my like terms first. I made sure there wasn't a variable on both sides, and then I got rid of the constant by adding 28 to both sides, so that was 25. And then I divided both sides by 25 and just got y equals 1. Okay? You're halfway. We still need to know what x is equal to, don't we?
Yeah.
Now, look, up here where it's solved for x, that's the easiest thing to do. The easiest thing to do is put a 1 right there where y is, so you're substituting again. You get 6 subtract 7, which is negative 1.
Yeah.
So x is negative 1, y is positive 1.
That's what I thought.
And just so you know, look, what happens if we put negative 1 right here where x is in the bottom equation? 4 times negative 1 plus positive 1, does that equal negative 3? See that it works? This is the only point then that's going to work in both of our original equations. No other ordered pair. And think about this visually, right? If we were to graph them, negative 1, 1, that's the point where they would intersect, exactly right there. You getting it okay? Okay, so I'm going to give you one more to do. But this time I'm going to make life a little tougher on you.
Oh, fun. That sounds great.
Not much though. So here's our system, and you'll notice neither of the two equations is already solved for x or y. Okay? But we can solve one of them for x or y, can't we? Which one? Top or bottom? Top? You could solve the bottom one for y, but I think the top one, what do you want to do? Do you want to subtract y from both sides and then divide by negative 1? Or just add x to both sides? Okay, everybody add x to both sides. So if we add x to both sides, that's gone. There's y, and you understand where you're going to put it? Make sure you replace that y with parentheses and put that negative 4 plus x inside. It's going to make a big difference. Now, if you're not getting an integer answer, check your signs. Make sure you took the opposite of -4 and the opposite of x when you remove the parentheses. Make sure you use the distributive property there. Two?
Oh yeah. Oh yeah.
So if you didn't use parentheses, or if you didn't use the distributive property right here saying, okay, I need to subtract -4 and I need to subtract positive x, so the opposite of -4 is +4 and the opposite of x is -x, that'll get you right there, won't it? Okay, you're halfway done. Now what?
Now we gotta figure out what.
We can just put that 2 right here, can't we?
Oh yeah.
So -4 plus 2. What's that? -2. So y is a -2. So let's give our answer like an ordered pair.
Go -2.
What do you think?
Oh yeah.
Solved by, what are we doing?
Substitution.
Substitution, right. Solved by substitution.
Oh,
Okay. So, if you turn to page 226, please. 226. You see a picture with a couple of clowns sitting there. Clowns are not terrifying, at least not until Stephen King. I'm still not scared of clowns though, because I'm scared of scary movies and I will not watch them. So since I haven't seen that movie, I still love clowns.
Did we turn 5.1?
Why don't you like scary movies?
Because they scare me.
Mr. Clark, did you turn it?
No, don't do that. We're talking about this problem yet. Hold on. Okay. So, a drama club earns $1,040 from a production. I'm going to write that down. So whenever I do a story problem, whenever you do a story problem, every number they give you, write it down and label it. Okay? If you come up and talk to me, Mr. Caller, I don't know how to do this story problem. The first thing I'm going to look at on your papers, have you written down what they've given you and labeled what they are? If you haven't done that, then you're not trying. Okay? You need to try. A total of 64 adult tickets, 64 adult tickets, and 132 student tickets. 132 student tickets are sold. And an adult ticket costs twice as much as a student ticket. So these are times 2, is that okay? So this is enough information for us to write 2 different equations, okay, using 2 different variables. But first of all, we have to think about, well, what 2 things are we looking for? So what is the price of each type of ticket? So what are the 2 variables here that we have? An adult, the price of an adult ticket, you okay with that?
Yeah.
And S, which is the price of a student ticket. Okay. S is a terrible variable because it looks like my 5s, but we'll go with it, okay? So with those 2 variables, what we need to do is we need to come up with 2 equations where we talk about how much each one is. Okay? So, so this is the price of each ticket. So I'm going to show you the first one. Every system like this has 2 things. First of all, it talks about the value of each one. How much are they worth? So do you think that the adult tickets plus the student tickets is going to equal $1,040? If we were talking about the number of them. Okay, so this is the price. So does the price of an adult ticket plus the price of a student ticket equal $1,040? One adult ticket plus one student ticket. Is that?
No.
I got one no. I got a few head shakes.
Probably not.
Probably not. That would be an expensive production, wouldn't it? Okay, so probably not. So what do we know though? How many adults came?
64.
64 times the price of an adult ticket plus, okay, 132 times the price of a student ticket. It's got to add up to 1,040. Okay, so that's one equation. Now the problem with this one equation is there's lots of different combinations that'll work. Like you could sell 0 student tickets and just have the adult price really high. Okay, or vice versa. Or there's just, it's a linear equation. There's lots of possibilities here for the prices. Okay? But what else did they tell us? They told us adult tickets were 2 times student ticket price, right? So they said that, now listen, they said, watch, the price of an adult ticket is 2 times the price of a student ticket. Isn't that what they said? Is that an equation?
Yeah.
I don't know. Yes. But I
Yeah.
don't know why.
They literally say that an adult ticket price costs twice a student ticket, or is twice the price of a student ticket. That's an equation. Now I want you to notice the 2 different equations. One of them talks about the value, how much they're worth. The other one talks about the number of them, or in this case. So they'll always look kind of like this. Now is that, we have a system. We have 2 equations and 2 variables. Can we solve this thing?
Oh, yeah.
Yeah. Where can we put this 2 times s? Right, yeah, right there. 64 times 2 times s plus 132 times s equals 1,040. That's the system that we can solve. Let's do it. You guys got a calculator going? 128 and 132 is 260. Divide both sides by 260. That's where you guys come in. Somewhere around 4?
Yeah, that's my guess.
4 on the dot.
On the dot.
Okay. I'm
So,
smart.
a student ticket costs $4. You okay with that? Student ticket costs $4. What about an adult ticket?
8.
Okay, so there's our answer. Student ticket, $4. Adult ticket, $8. And that's the only combination where adult tickets can be twice as much, and we can have 64 adults and 132 students and have them add up to this value right here. Now, are you going to be given a story problem like this? Very, very, very similar to this?
Yeah.
Yeah.
Okay, so you should be able to set it up and make that happen. So I'm going to give you the problems for 5.2, and you guys are going to hand in 5.1.
Are we going over the answers, or are we just trying to make
Just go ahead and hand it in. You guys have had it for a while now, and I will grade it and